For over 34 years, the Hubble Space Telescope has been one of the most important tools in astronomy, offering groundbreaking insights into the cosmos. Originally designed for deep space observations, Hubble has also become a powerful instrument for studying our own solar system, capturing detailed images of planets, moons, asteroids, and comets. While many solar system bodies remain unexplored due to limited missions, Hubble has helped bridge the gap. Its observations have revealed strange and surprising phenomena, reshaping our understanding of planetary science. However, Hubble isn't suited for every target. It can't capture the full moon in one frame due to the moon's large size in the sky. That task is better handled by missions like NASA's Lunar Reconnaissance Orbiter. Still, Hubble has played a surprising role in lunar science. In 2012, it helped observe the transit of Venus across the Sun. Scientists bounced sunlight off the moon to study how Venus's atmosphere scattered light. This clever setup allowed researchers to confirm the presence of gases like carbon dioxide. More importantly, it demonstrated a method that can be used to study the atmospheres of exoplanets, something astronomers now do regularly in the search for habitable worlds. Mars, in contrast, is perfectly suited for Hubble's instruments. It has taken full disk images of the Martian surface, which orbiters can't easily do due to their proximity. Hubble has helped monitor dust storms, seasonal changes, and even tracked weather patterns over time. One iconic moment was in 2001, when a global dust storm engulfed the planet, blocking its surface from view. Such observations are crucial for planning future missions, including those carrying humans. Hubble has also observed Phobos, Mars's larger moon, which orbits extremely fast, completing one revolution in just 7.5 hours. Over time, it's being pulled closer to Mars and may eventually crash into the planet or break apart into a ring. Watching such events helps scientists understand how planetary systems evolve. Beyond Mars lies the asteroid belt. Hubble has studied many of these ancient rocks, left over from the early solar system. One fascinating target was asteroid 6478 Gault, which developed two tails like a comet. This strange behavior was traced to the Europa effect, where sunlight changes an asteroid's spin, causing it to shed surface material. This suggested that many asteroids aren't solid but rather rubble piles held together by weak gravity, easily disturbed and reshaped. Another key discovery was P-2010A2, an object initially thought to be a comet. It turned out to be debris from a high-speed collision between two asteroids, creating an X-shaped pattern and trailing material. Events like this, though rare, reveal the violent, chaotic nature of the asteroid belt. Further out, Jupiter plays a powerful role in shaping our solar system. Sometimes called the solar system's vacuum cleaner, Jupiter's gravity can deflect or capture objects that might otherwise head toward Earth. With a mass equal to 34% of all non-solar matter, its influence is second only to the Sun's. In 1994, Hubble captured one of the most dramatic events in modern astronomy, the impact of comet Shoemaker-Levy 9. After being torn apart by Jupiter's gravity, the fragments slammed into the planet's atmosphere at 60 km per second. The impacts produced fireballs 3,000 kilometers high, reaching temperatures hotter than the Sun's surface. One impact left a scar the size of Earth and released energy equal to 6 million megatons of TNT. This event vividly showed how Jupiter acts as a shield for the inner planets, including Earth. Hubble has also studied Jupiter's powerful auroras, massive light displays hundreds of times more intense than Earth's. Unlike Earth's auroras, which are driven by solar storms, Jupiter's are continuous and fueled by both solar wind and its own intense radiation belts. In 2016, Hubble's long-term data helped support Juno's up-close study of these stunning features. Among Jupiter's moons, Europa stands out. Beneath its icy shell lies a vast subsurface ocean. Hubble has spotted plumes of water vapor erupting from its surface, hinting at geysers that may connect to this hidden ocean. Spectral data has even revealed the presence of sodium chloride, common table salt, suggesting that Europa's ocean may resemble Earth's seas, raising hopes it could harbor life. After the Cassini mission ended in 2017, Saturn was left without a dedicated spacecraft. Hubble has stepped in to continue observing its storms, atmosphere, and iconic rains. It has also helped track the ice giants, Uranus and Neptune, both of which remain largely unvisited since the 1980s Voyager 2 flybys. Hubble has documented seasonal shifts on Uranus and even discovered Neptune's smallest moon, Hippocamp, likely formed from the remnants of a moon collision. For over 3 decades, the Hubble Space Telescope has surpassed expectations, transforming our understanding of both distant galaxies and familiar neighbors. With proper servicing, it could continue functioning into the 2040s, possibly outlasting even the James Webb Space Telescope in certain roles. As we push deeper into space, Hubble's legacy reminds us what's possible when human curiosity meets cutting-edge technology. The universe still holds countless secrets, and thanks to Hubble, we've learned that every new observation can lead to a discovery that changes everything.